Hello everyone, welcome back to our lesson video 3 with programming in C++. Today we are going to talk that by the end of this video, you know how to create a pointer, how to assign addresses to pointers, how to dereference a pointer, also how to create a reference, and we also talk about arrays, how to initialize arrays, how to access arrays elements. So without wasting much time, we dive into it. So what are pointers? So let's take a pointer. Let's imagine a pointer as a piece of map with a location or address of a particular house on it. The map doesn't contain the actual house, it contains the address. That's what a pointer is. It is a variable that stores another address, that stores the address of another variable in your computer's memory. Instead of storing the actual value, it stores the location that the value can be found. Pointers can be used with any data type, whether integers, characters, floating point numbers, or even other pointers. So let's talk about how to create a pointer. Creating a pointer is similar to creating another variable, but we use a special key, which is the asterisk sign symbol. For example, we want to create a pointer that can point to an integer number. So let's do the practical example. So we do int, which is the integer data type, then the asterisk, then bring the pointer identifier, which is the PTR. So that's my pointer name, and we terminate it. This creates a pointer called PTR that can store the address of an integer variable. Notice the asterisk over here tells the computer, the compiler, that PTR is a pointer, not a regular variable. So let me assign a value to this pointer. To assign a value to this to a pointer, you need to write the value, the assignment operation, and your value, which is maybe 26, then terminate it. To make our pointer point to this variable, we write this int, the asterisk, and PTR, which is the pointer, and this ampersand. Oh, I forgot to bring my assignment operator, sorry. The value, then terminate it. The ampersand gets the memory address of the variable VAL, and we store that address in our pointer PTR. Now the pointer PTR knows exactly where to find the value 26 in our memory. So let's talk about referencing a pointer. The process of accessing the actual value that a pointer points to is like following the address on the piece of map to visit that actual house you are going to visit. Here's how it works. So we do this cout. Cout asterisk PTR. Then we terminate it. So the asterisk PTR tells the computer, go to the address stored in PTR and give me the value you find there. This will print the actual value of the variable PTR is pointing to. So let's run this program in. Voila. So we see the address is pointing to 26. Let me give one more example. Let me do one more example of this. So another one, int number equal to maybe the assignment operator, and the value is 42. Then meet it. Int ptr, it's my pointer, assignment operation, my ampersand and number, which is the memory location of my ptr. So let's see. Let me see if we can get the address of this line of code. Let's see out. Address of oh, sorry, I didn't bring my asterisk sign over here. Let's run the code again and see. Now, this is the address of my integer variable. So this store the address of the integer variable. So let's also ask the pointer to point to the number, the actual number of the code, the variable value. Oh, see the 42 here. That's the actual number the pointer is pointing to. So let's talk about modifying the pointer. One good feature of a pointer is that you can change what a pointer points to. As long as the new variable is the same type, the same data type, you can reassign the pointer. So let me do another example here of how that works. So let me take int a equal to 5, comma b equal to 10. Implement it. So this one is also known as multiple declaration. Yes. So int and my asterisk sign over here. ATR, which is my pointer. My ampersand is a location. See out. See out. BTR. we can see that the pointer is pointing to 5 over here. So let's reassign the value of the pointer. TR, which is the pointer, equal to B. C out. TR. See that the value over here has changed to 10. So that we are assigning the pointer, the value of the pointer from 5 to 10. So let's talk about the data size of a pointer. Every pointer has the same data size, like it's a constant something. With a 64 bit system, the pointer, the size of the pointer is 8 bytes, and for the 32-bit system, the size of the pointer is 4 bytes, whether it's integer or anything. You take the same amount of memory. So let's talk about references. Now, a reference is like giving a nickname to an existing variable, where when you use the reference, you're actually working with the original variable directly. It's like if your name is maybe David. David, people can choose to call you Dave. The same refers to the same person. Similarly, a reference provides an alternative name for an existing variable. References are very useful because they allow you to work with the original data without making copies, which can be more efficient. So what's the difference between a reference and a pointer? The key difference is in how they are used. Pointers allow us to pass large amounts of data around efficiently. Instead of copying all the data, you just pass the address where the data is located. References also provide a more direct way to work with the original data. They are like having a direct connection to the original variable. While pointers are like having the address where you can find the variables. So creating a reference, you need your data type, your identifier, your assignment operator, and a value. So, so let's create a reference. Reference int y, assignment operator, and value maybe 20. So int creation of ref means reference equal to y, and then we terminate it. We terminate this one. So the ref is a reference to y. Now, ref or ref is essentially to another name of for y. When you can change ref or ref, you're actually changing the value of y or y and vice versa. So here's an example of the reference. So you need your value, your int, your identifier, your assignment operator, and your value 20. Terminate. Before that, we have to do the void over here, like create the void function over here. Void modify value to bracket int and y. Where y, that y is equal to 20. This we are modifying the original value of y. So let me say 15. No, modify value. Y. Then we terminate this one. Come down. Then you ask you to output the value of y. Okay, because of this thing. So we can see that the value of y is changed. Now let's talk about arrays. Now, an array is a collection of multiple objects of the same data type. This stores one after another in memory. Array is like row of lockers in a keyboard dressing room. Each locker can hold an item. They are all the same size and they are numbered sequentially. Individual items in an array are called array elements, and we can access each element using its position number called an index or subscript. To create an array, you need the data type, name for the array, and the array size. So let me say data type for use float this time. Float. Using namespace std. Okay. You need a data float data type. The name of the array is say AR for array and the size 10. Then we terminate it. This creates an array called ARR that can hold 10 floating point numbers. The data size of this array will be the size of float multiplied by 10, which is float is 4 bytes multiplied by 10 to 40 bytes of memory. So what are array indexing? Array indexing is how we access individual elements in an array. The index specifies the position of the element in the array, and it starts from 0, not 1. When we are counting the index, it starts from 0, don't start from 1. We use a square bracket to access the element. So let me say this is how it looks like, the ARR. This is the first element, second element, and third element. We are not choosing 1, 2, 3. We start from 0, 0, 1, 2. So this is array of 3 elements, 0, 1, 2. Let's talk about initializing an array. When we create an array, we often want to give it initial values. We can do this by providing a list of values in a curly basis. So example is int num. So the size of the array is 3 equal to. So we are initializing numbers to the array. Which is we have maybe 40, 50, 70. Then it makes this one. Now this creates an array with 3 elements. So the first element is which is 30, is 0. When you are counting it, its number is 0, and if 50 is 1 and the 70 is 2, rather than counting it 1, 2, 3, that's wrong. So we also can also let the system identify the size of the array by doing this. The system will do that always. Its number. So let me do one example for you. Int numbers the 5 numbers. First one is 10, 20, 30, 40, and 50. So this will print all the elements. Print all elements. For int, I equal to 0. I is less than 5. The intermediate one, I increment. See out element. numbers. And like increment. So as we can see, for the position of 10 is 0, 20 is 1, 30 is 2, 40 is 3, and 50 is 4. Though it's five numbers, but you have four positions because it starts from 0, not 1. So let's access array element. Accessing an array element, we use the array name followed by the index in the square braces. So example is, do example. Int, say score 5 element, which is 75, 80, 85, 90, and 95. That's my scores. So, say accessing this, let's see out. Scores, which is index is 0. Run this today. Scores was not declared in this school. No, a spelling mistake, sorry. Let me clean this S. Then run it. Squad and write scores. So we can see the value here is 75. Because the index for the position of 75 is 0. So let me change this to 3 and see. Change this to 3, we will output 90. As you can see here. So we have other dimension of arrays. You have multi-dimensional arrays. So multi-dimensional arrays, it's like a single row of lookup, but it can also create multi-dimensional arrays, which are like having multiple rows and columns. And a two-dimensional arrays is like a table of spreadsheet with rows and columns. The syntax is like int the array name, and do int array name is a matrix. 3. So this creates a 3x4 matrix. 3x4 matrix with 3 rows and 4 columns. So the total element will be 12. We also have 2D arrays, two-dimensional arrays. Can be visual, like say the spreadsheet. Each element is accessed using 2 indices, one for the row and one for the column. Right. So I have three-dimensional arrays. Add another dimensions or depth. It's like having multiple layers of a 2D array stacked on top of each other. This is how it looks like. Another one is we have 3 here. Change this. Okay. array. This creates an array with four arrows, three arrows, three columns, and three layers deep. It's like a Rubik's cube. That's how it's like. So the four that 3D arrays, typical example of 3D arrays like a Rubik's cube. Thank you very much for watching my video.